So number one, Mr. Krutz is traveling to IU to visit his brothers. The table below shows his driving time and distance. Review real quick. X-intercept, what is it? I mean, my X value is time, yes.
Yeah.
That's not my X-intercept though.
The x-intercept should be an ordered pair, remember?
So that's gonna be X, use this for Y. I'll give you a hint. My X-intercept, I'm gonna have a value for my X. My Y is going to be 0. For my Y-intercept, I'm gonna have a value for my Y, which means my X is going to be 0. So if I go to this table, I want to find what Y is 0, which is right here. So my X-intercept is 60, 0. Let me go back to my code. That's my X-intercept. Okay? And in the context of this equation, this problem, what that means is at 60 minutes, Mr. Krutz has 0. Actually, instead of saying that, I'm going to say has arrived at I. Because if he has zero miles to travel, that just means he's arrived at his destination. So at 60 minutes, theoretically, Mr. Krutz should be at IU.
Theoretically.
So if we know, we've already identified my X-intercept, so what's my Y-intercept? Somebody give it to me. Remember, we're looking at our table. We want to find where we have our X value is 0. So on my table, my X is that top one. So where does it say 0? It's okay. I'm gonna work with y'all. Don't worry. I know y'all still sleepy. So my Y-intercept is going to be 0, 60. And basically what that means is at 0 minutes, I'm gonna write the word 0. So at 0 minutes, Mr. Krutz has 60 miles that he has to travel. That's what that means. In other words, he hasn't started yet, he's still out. Number 2, remember in our Y-intercept form, slope-intercept form, -3 represents our Y-intercept, which means, I said -3, B represents our Y-intercept, which means I'm going to look here and find a point that crosses my Y, which is right there. That's a +3. That means I can eliminate off the bat A and C. It's going down, both of these are negative, so they're both still in the running. Now when I do my M and look at my M value, I want to look until I see another point that touches on this line right here. As you can see, I have a point here that touches on that line.
You wanna make the triangle.
And if I go over and count, that means I'm going down 1, 2, 3 to my right 1, which means my slope is a -3. make my answer B.
When you say -3, it's kind of like writing a fraction, -3/1. So -3/1 is not the same thing as -1/3. They're not the same. So your slope is a -3. You go down 3, 1 to the right. When you divide a positive by a negative, that's where you get the -3 from, not 1/3. All right, you good with that? Makes sense?
And then for this last one, we want to take this and convert it into y equals,
My guy.
we're going to convert it into y equals mx plus b. That's what we want to do.
So who has to go? Who needs to go to the other side?
We want y by itself.
So who moves first?
Right now, we have somebody third wheeling right now. We got a couple of third wheelers.
No? We're talking about, oh, no, wait. On the first one, the one you circle, who has to move away from the Y?
This is a couple. He's third wheeling.
Oopsie.
So we're gonna get rid of 2x.
How do you get rid of 2x? You just take it and get rid of it? Do you add it or subtract it?
Something, you subtract it, because remember that 2x is still a positive 2x. So the opposite of a positive is a negative. So we subtract 2x from each side. That should leave us with 3y is equal to a negative 2x. And then we still have this positive 6 over here. We're close, but we're not done yet. Y wants to be single. She's tired of her man. She wants to be single. In order to get rid of this 3 that's being multiplied by my y, I'm going to divide each of my 3 numbers. That's important. Each of my 3 numbers have to get divided by 3.
If you divide the right side by 3, you gotta do what? Divide the left side by 3. That's everything on the right side. Not one, but everything.
Everything. Cancel. Ooh,
I did that today. It's okay.
that's
We
gonna
gotta get
cancel
back on
those
the
out.
bus too.
We're just gonna leave it with y equals. Remember, when we graph, you want to leave it in a fraction because that'll help you out. -2/3x
Plus 2.
plus 2 because 6 divided by 3 is 2. Why did you not change?
Look at him color coordinating up there.
Plus 2. Let me write it bigger.
Push the thing up.
You're right.
Slide day. Every day is a learning day.
Every day.
So if you got a -2/3, is a line gonna fall or is it gonna rise?
I do that last one. You don't even
It's
do
gonna
it.
fall. What's your y-intercept? What's the y-intercept? 2, not really 2. What's your order pair? What's your order pair for the y-intercept? No, that's your slope. What's your order pair for your y-intercept? How would you write that 2?
2.
2 is right, but what's the ordered pair? 0, 2. Why is it 0, 2? There you go. See how you guys make that circle come back to their first bill word problem?
I thought you said 2 was wrong.
No, it's not wrong. I said, but what is the ordered pair? The ordered pair is 0, 2. You feel me?
That's an order pair. You need that. We'll go ahead and go to your books, page 307. I'm assuming all of y'all have that down. If you don't, we'll
Everybody got a
have it
book?
on a piece of paper. I'll probably afford it.
Okay, go in that book bag. I know y'all ain't been in there a couple of days. I ain't mad at you. I didn't go to mine either. I was in the car until this morning, yep, just tell the truth. Go to page 307. Girl, you don't need a book. You need a piece of paper, but it's my stuff. Where's your book at?
I've been at this school every day for the past 3 months.
Okay. That's the life of a coach.
We're gonna talk about correlations
You
today.
don't have it?
Slopes are still important. So if something has a positive correlation, all that means is, there it is. On our graph, I'm gonna use green for positive and red for negative for y'all. Is that all right with y'all? So positive, because my points are going up on my graph, that means it's positive correlation. A negative correlation means that my points are moving in a direction that is going down, negative. And obviously no correlation means that they're just points all over the place, but we don't know if it's going down, we don't know if it's going up, because it looks like it's going both down and up, they're all over the place, there's no correlation.
All right, so for some of y'all that are sitting there, if you have a positive correlation in the right-hand side of your book somewhere, go in X, as X increases, Y increases. Okay? So make sure we use the word increase and decrease. Not going up, going down, that'll, you know, depends on who you're talking to. All right, so it's very important that we use the mathematical words, increase and decrease. As this happens, something else happens. As you increase your study time, your grade in the class should increase. As you increase your bedtime, if you go to bed earlier, you should not be sleepy at 9:15. As you decrease your cellular screen time, your eyes should be better. Got that? As you decrease the cellular screen time.
We good? I can move on? Cool. The scatter plot displays the height and weight of New Orleans Saints football players. Determine whether the scatter plot shows a positive, negative, or no correlation. So what do we think? Positive, negative, no correlation. What do you guys think? You said no correlation? I don't know. I think I like positive. Because on a whole, as I increase in my X values, what's my Y value doing? Increasing as well. And I mean, think about it in real life. Typically, people who are taller tend to do what? Way more. I'm not saying all the time, but you're really not gonna see somebody who's 5'2" and weighs 180 pounds. That's a little ridiculous. I'm 5'10", I weigh 180. If I was 5'10", I weigh 300 pounds. That's a little ridiculous. But Shaq is 7 foot and he weighs about 300 pounds. So typically, the taller you are, the more you weigh, just because you have more mass. This is how that goes. So this is a positive correlation. Y'all got that? I can move on? Yes, 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 yes. No. What you mean no? You can't see that? Okay. I was gonna say you can dang near sit. So you can dang near sit there. I don't know. I'm trying to help you out. We'll see though. It's okay. You got your picture though? Move on. Up. So for this kind of point, positive or negative correlation? Oh, we got a sleeper. Oh yeah, come on, man. We got a couple sleepers. Ugh. Some of y'all can move. We're still on the phone. We need a break though. It's okay. I know. Go ahead, huh? Okay. Positive correlation. Somebody, you know what? It's cool. We're gonna snake around the room. We're gonna start with Eric. We're gonna work our way over. Don't worry. Eric, positive or negative correlation? Why?
That X is increasing, Y is decreasing.
Look at that. He sound more like a math teacher than I do. As our X value increases, our Y value for the most part are decreasing. So in other words, as time increases, the number of landlines generally decreases. This word generally is huge because if you look, we have a slight increase here, but as a whole, they're going down. Y'all got that down? You got your picture? Decided to start doing for y'all, which doesn't mean you don't take your own notes, but I'm gonna upload notes on the campus every day, so y'all have them. Like I said, it doesn't mean you don't take notes in class, you still want your own notes. And that way, if you miss a day, I don't have the notes from this day. Well, if they're on campus, go look at them. I might wait and do it at the end of every week, so that way y'all still have to take notes, and y'all can't just sit there and wait for me. I think that's what I'll do. That's also why I'm recording the lesson too. And I think I'll upload them every week. So we'll see. Moving on. So for A, my bikes. Davion, is this a positive, negative, or no correlation?
No correlation.
You say no correlation? Why is that?
Because none of them are direct related.
In math terms, my X and my Y seem to be unrelated. Right? As my X value increases, my Y is just kind of doing its own thing. They're not related. So since they're not related, no correlation. What about here? B. Is B a positive, negative, or no correlation?
No correlation.
This one.
Positive.
Not positive.
Negative.
So negative correlation, right? Look, generally, as my X value increases, my Y values are going down, right? Now this point right here, this is what we call, oh, that must be what we call an outlier. So like if we were doing something, we were collecting data, typically outliers, we make notice of them, but also understand that they typically don't represent the trend, right? So like to make it into a sports analogy, Steph Curry, especially when he started, especially from 2014 to 2017, when the league was still trying to adjust to him shooting deep threes and the volume of threes he was shooting, he would be an outlier in terms of 3-point shooters, just by in both his efficiency and his volume. So like if we were to have a scatter point, we put everybody in the league, everybody would be in one spot typically around each other, and then you got Steph Curry just somewhere in his own little spot. That's an outlier.
That's good. I didn't think about that today. All right. Creating that little game.
But yes, this is a negative correlation. Sports is an easy one. I can move on.
Sorry. You know how I am.
Scatter point. Now we're going to talk about strong or weak correlations. Well, not quite. I'm moving a little ahead. Go to your package, page 2. That first one was the first page of the packet. The second, I just know where it's going. I just, I'm a little too early. Cause I mean, I'm there actually. Now that I see it,
Yeah, you
oh,
are.
I am there. Look at me.
You good.
Losing my mind a little bit, but it's okay.
It's okay.
Teaching math will do that too. So scatter plot is a type of graph that plots points to show relationships between two variables. Points may or may not form a shape such as a line. These plots are scattered throughout the graph. When looking at a scatter point, the data can have either a strong or weak correlation. So what do keep everything in green? So strong correlation, right? The points take the shape of a, what do we think that's gonna be? There we go, a line. The majority of the points will be close together. So, as you can see in our example right here, this is an example of a strong correlation. We're not saying it's going to form a perfect line, but if you look, you can kind of see, if you squint at it, you can kind of see a line being formed there.
You say squint at it.
It says squint at it. Like abstract art, you know, you gotta squint at it. It's there. You can see the line being, you can see a line being formed. On the other hand, weak correlation, the points are what?
Think about it.
What's it called? It's called a what? So yeah, there you go, scatter. On the graph. With them often being far away. So this one, see how these points are kind of far? Can't really form a nice coherent line. You squint at it, you still can't even really see a line there. That's a weak correlation. Put it in red. Make sense? I can move on? You shaking your head no, so it doesn't make sense? Think of it like this. If we're in a group, actually hold on, you know what? I'm gonna use a game. I don't know if y'all ever played this game.
The word man.
I don't know if Miss Smith has, or at least she's heard of it. Y'all know the game Red Rover, right?
Red Rover, Red Rover.
For those of you that don't know, basically, it's a bunch of people. Eventually, you got a wall of people holding a link of arms, right? And we'll say Red Rover, Center. We'll just call a random name, and they have to come to us. The point of them is they're running as fast as they can to try to break our arms, right? They're trying to break through our arms and get through. the tighter we are together, right? The closer we are together, the harder it's going to be for that person to run through us. But if we're all spread out and we have a bunch of gaps, that's a weak connection. It's easier for that person to run through. It's kind of the same idea with the points, right? The closer together the points are, the stronger the correlation is. The farther away they are from each other, the weaker it is. And that's why when you have a strong correlation there together, a lot of times I end up forming a line. Make sense?
Makes sense to me.
See, I know y'all never played Breadcrumb. That's a dangerous game. It's a clothesline waiting to happen.
Good.
This is what, strong?
Yes.
Yep. I'm saying this like I don't have enough.
It's okay.
It's okay. Oh no, it's not. See, I know it's gonna mess it up. It's positive. No, it is.
It's strong.
It's strong. So strong correlation, the points take on the shape of a line with a, should be a positive.
Positive slope. And then I wrote, goes up from left to right, and I wrote, there's some people ain't gonna never know which.
So after we talk about it, let's go to our nice little example. Strong correlation, right? We got a line that's going where? Left to right. Y'all see how it's going left to right? Left to right. Strong correlation. Like we said, since it's also going left to right, means it's positive. Because as our x value increases, our y values generally do what? Increase. So a weak correlation, the points take the shape of a line with a negative slope. Put that here. So obviously, as you can see, our second example, strong or negative correlation, or weak, I said negative, strong or weak correlation. Hello,
Hello?
hello, strong or weak correlation, what do you think? I'm still saying strong, because they're nice and together. We're still going left to right. But it's going to be negative because it's going down. As you can see. Going down. Trying to fight your sleep, so it's not working though.
I know, it's hard.
Trying. I seen that one eye open. He was trying. He's sleeping like a dolphin underwater. Why I leave off that? I'm gonna give you all 2 minutes. Do it on your own. And then we'll come back as a group. You have to give me your answer. Just for these first two though. Number 5, we'll talk about it as a group again. I'll bring you, but 2 minutes, if that. Really, I really don't need one. Take a minute. Tell me if they're
Yeah,
strong,
like it.
weak, positive, negative.
I'm struggling this morning.
They're the ones that came here, so imagine the ones that stayed home.
We appreciate it.
100%. You're supposed to tell me.
The first one we and I
You asked me, you're supposed to be telling me. I told you to tell me. I don't know nothing now. I'm not the teacher right now. You're the teacher. Go mark it on it. Go ahead.
I'm not right. I don't know.
It's okay. You just see me get something wrong on the board today. Y'all can't be afraid to be wrong. You can't learn if you're not wrong. It's okay if you're gonna be wrong. It's okay. How many times do you think I'm wrong a day? Well, I promise you it's more than right. But hey, I always like to use this example because some people like to believe that Michael Jordan is the greatest basketball player of all time.
Oh.
Even though he's not.
I think it's LeBron.
It certainly is.
But that's because I grew up watching LeBron, so that's why it's easy for me to say. But Michael Jordan is consistently considered the best basketball player of all time, right? You know what his career shooting percentage is his career field goal shooting percentage is?
You said last time. I can't remember.
49%, meaning he still missed more shots than he made. But nobody cares about the shots he missed. We only remember and look at him for the great games he had, all the
That's
shots
right.
he made.
That's all we got.
But in his career, in the games, he missed more shots than he made. So y'all just have to understand, if you're wrong, oh well, nobody doesn't care how many times you were wrong, because once you get it right, that's all everybody cares about. So go up there, mark it up there. If you're wrong, you're wrong. There's probably 10 people in here that are wrong. You don't want to get up, well, okay, that's fine. At least tell me what you got. So you said stronger, weak correlation.
I low-key forgot. We're gonna go for
Low key, you forgot?
Well, let me,
We're
that's
gonna go
cool.
weak.
You gonna go weak?
I think I said strong first time.
Well, you're saying weak this time. So is this a positive or negative correlation?
It's going left, negative.
She knows a little something. See, I don't know
She
why
just be playing around.
I don't know why she doubted herself. She's 2 for 2. Weak because their points are kind of all scattered all over the place, right? Can't really squint and see a line. So weak, I agree with you. And then negative because as you move left to right, as your x values increase, your y values have that tendency to decrease.
That was right.
Yes, I told you 2 for 2. I don't know why you were scared to come up here. You were 2 for 2. Lord have mercy.
Don't tell her that. She don't want to be wrong.
You okay, Sid? You want to help me out with this second one? What kind of? I'm trying to politely demand that you help me out with the second one. I told y'all this classroom's not a democracy. This is a dictatorship. Y'all gotta understand that. Y'all don't have no words, no saying what's going on.
Why is it weak and straight?
Uh-huh.
So that one weak correlation is positive. This one's negative.
I would agree with you. Well, Miss Pittman's up today.
Well, she is.
Now we can talk about number 5 together. Y'all see this nice graph, right? Nice little chart. Now we're gonna throw in numbers to you when we're talking about correlation, when we're talking about strong and weak. So the closer, we're gonna ignore this negative sign right now, right? We're gonna ignore it when we talk about strength. The closer your number is to 0, the weaker your correlation is. 0 means there's no correlation. 1 means it's a very strong correlation. Numbers in between varying on strength. Obviously, the negative and the positive sign just means if it's a positive correlation, if it's increasing, or if it's a negative correlation, if it's decreasing. The coefficient value, which I think she used as R, if I'm not mistaken.
Yep.
R is the value that tells you what are the 2 things in there? somebody can read, I'm happy. The strength and direction of the relationship between my two variables. I know we're almost done this cool. We're about to, we're literally almost done with the lesson. So if I go over here, and we can do this real quick as a class. This one's the easiest one to identify. Everybody said this was a negative, which to me makes sense. It's real close to a line. Really probably just 1 point away from being a line. Really, you could probably put really negative 0.94. I think I would have took that too. We're going to use process of elimination here. So for this first one, we know it's going positive, it's going up. So anything that has a negative number in it, it can't be. This correlation looks stronger than weaker. So we know it's not going to be any of these values that are kind of close to 0. I know they have, it's okay. It's for the video, that's why I'm taking it. So, they still got the lesson on the video. So, when that happens, process of elimination, I don't think it's quite strong enough to be 1. I think it's 0.9. So for this one, 0.9. And then this last one, again, we know it won't be negative.
It's 0.5.
I don't think this correlation is that strong. I don't think it's that weak. So I'm gonna put 0.5. Remember, don't be afraid to use your middle one as a comparison, compare and contraption to. Eliminate all your stuff is, this is how it has to be.
So that's how it is.
Mm-hmm.